Okay, let us discuss this problem. So this is something related to redox titration. This says 10 ml of, so I have 10 ml of 1 m aqueous solution of Br2. So 1 m Br2. So this is given to you. This is added to excess NaOH in order to disproportionate. So this is added into excess NaOH. So I have taken excess NaOH. So NaOH is taken in excess, so that it disproportionates. So Br2 disproportionates. So what we are doing is, we have a flask. This flask contains NaOH, and we are adding Br2 in this solution, and Br2 basically disproportionate, and this gives me Br minus plus BrO3 minus. After disproportionation you are getting these two species. The resulting solution is made free from Br minus. So this solution, the resulting solution you have, of course this will be basic because NaOH is taken in excess. So resulting solution will be basic, and this is made free from Br minus. So free from Br minus, free from Br minus. So now we will have only BrO3 because we have made free the solution with Br minus. So solution will only contain BrO3 minus. Of course this will be basic because we have not titrated. The NaOH that is excess will be here, and still it will be here. Now the question says the resulting solution is made free from Br minus ion by extracting, and excess of NaOH is neutralized by acidifying the solution, and excess of NaOH, that is the solution, is basic. Now this is titrated with acid, so that now only remains BrO3 minus, that is the excess of base is neutralized by the acid. So question says excess of base is neutralized by the acid. The solution requires 1.5 gram of CaC2O4 for complete redox change. Calculate the percentage purity of CaC2O4. Now this final solution requires CaC2O4 for complete redox change, and the value of the weight of CaC2O4 required is 1.5 gram. And the question says for complete redox change, and in this case what you will have, what are the possible reaction you will have, that is very important. So what is the reaction happening here? You see the medium is acidified, so what do you expect the reaction that is happening in this step? In this step you see BrO3 minus can go in acidic medium in the presence of C2O4 2 minus, it will go in Br minus, and C2O4 2 minus, this will go in acidic medium, everybody knows this go into CO2. So the corresponding reaction will be BrO3 minus goes to Br minus, C2O4 2 minus goes to CO2. Now things are very simple, you can solve these equations. Just write down the equation, try to solve this one. So I will wait for 1 minute so that you can find the percentage purity of CaC2O4. So what is my target is, what is the percentage purity of CaC2O4? So let us wait for some time and let me see how many of you are able to do this one. So what is the percentage? So I have been given you the hint, that is the question says the complete redox change, in that case BrO3 minus is going to Br minus, and this C2O4 2 minus in acidic medium always goes to CO2. So let us find out the percentage purity. Okay, let us say we have x mole of CaCO2O4. X mole of CaCO2O4 we have. Now the next task is to write in the reaction. So C2O4 2 minus, this is easy one, 2CO2 plus 2 electron. Now the next reaction, that is BrO3 minus, goes to Br minus, and then you will have 3H2O. Medium I will assume acidic, so 6H plus. Now let us say add electrons. So this side you have minus minus, this side you have to add 6 electron, I think. Minus 1, yeah, of course, there's 6 electron here. Now if you do addition of these two equations, you will have to multiply this by 3. So if you multiply by 3 and add, what you will have 3C2O4 2 minus, plus this side you will have BrO3 minus, and rest I am not going to write because that is not my intention to find out those values. So let us leave all those values. So now I know the mole of CaC2O4, that is C2O4 minus mole of C2O4 is X. So I have X mole of C2O4 minus. So what is the mole of BrO3 minus? So 3 mole react with 1 mole. So X mole will react with X by 3 mole. So the mole of BrO3 minus is X by 3 mole. Now if I know the mole of BrO3 minus, I can use the next equation. So you see what we have. We now know the mole of BrO3 minus, this mole of BrO3 minus. Now my target is, if I know the mole of BrO3 minus, I can calculate the mole of Br2. So mole of Br2 can be calculated. The question says a Br2 goes to this proponent and it goes to Br minus, and another reaction you will have Br2 goes to BrO3 minus. Are you getting? So let us say we will have 2 multiply by 2, so we will have 2 electron this side. Are you getting? Now Br2, let us say multiply by 2, so we will have 2 into 3 6H2O this side, and then you have to add hydrogen, so 12H plus, and then you check for electrons. So this side I have to add 10 electron. I think all of you have done this one. Now I have to multiply, so let us check again. I think it's okay. So if it's okay, let us multiply this equation by 5 and then add these two equations. So first equation, if I multiply by 5 and add what we have. So if I multiply by 5, we have this side Br2, 5 Br2 plus Br2, so that is 6 Br2 plus 6H2O, electron cancels out. Now this side I require, we will have 10 Br minus and plus 2 BrO3 minus, and rest of the spaces I am not going to write, so let us leave those rest of spaces. Now I know the mole of, so this is Br2, not BrO, so this is simply Br2. Now I know the mole of Br2, that is we have so BrO3 minus, so we have calculated the mole of BrO3 minus, that is X by 3. So mole of BrO3 minus is given to you, X by 3. Now I want to find mole of Br2. So 2 mole gives 6 moles, 2 mole reacts with 6 moles, so 1 mole will 3 mole. So X by 3 mole will react with X by 3 into 3 mole. Are you getting? So that is the mole of Br2. And mole of Br2 can also be found using, so Br2 initially this says we have solution in which 10 mole of milliliter of Br2 with 1m. So mole of Br2 can also be found. So mole of Br2 that can be also found from 10 ml, that is 10 into 10 to the power minus 3 liter into 1 m. So this is the mole of Br2. Now I can equate this with X. So X is nothing but 10 into 10 to the power minus 3 mole. That is the mole of CaC2O4. So this is same as, because X is the mole of CaC2O4. So mole of CaC2O4 is mole of CaC2O4. This is equals to 10 into 10 to the power minus 3 mole. So what is the weight of CaC2O4? So weight will be simply I have to multiply by the molecular weight. So molecular weight of CaC2O4 is given to you. So this is 128. You can verify yourself. So weight of CaC2O4 is CaC2O4. This will be equals to 128 into 10 to the power minus 3. So this is basically equals to 0.128. So this is 10 to the power minus 2. So this is 1.28 gram. Are you getting? So what is the percentage of CaC2O4? So percentage of CaC2O4 will be 1.28 divided by 1.5 into 100. Because the initial sample was 1.5 gram. So CaC2O4 initially it was 1.5 gram. So let us calculate this value. So I think you have copied this one. So if I do calculation, so 1.28 divided by 1.5 into 100. So this comes out to be 85.33%. Are you getting? So this percentage you see here, this comes out to be 85.33%. So this is 85.33%. So this is the mole of CaC2O4. This is the percentage purity of CaC2O4. So what we have done is, in this question you see, important point we have, in the first reaction Br2 goes, so this is the disproportion reaction. In the presence of NaOH, Br2 goes in the form of Br minus and BrO3 minus. That you have to remember. And the second reaction that is also very important, that in the presence of CaC2O4, BrO3 minus, that is going into Br minus, because C2O4 2 minus goes to CO2, that everybody knows. That is a oxidation. So BrO3 minus has to be reduction. And this question says complete reduction, complete oxidation change. So BrO3 minus, that is basically oxidation state for bromine is +5, and this has to reduce. I need reduction because C2O4 2 minus goes oxidation, so this has to be reduced. And question also says complete redox change. This means bromine will go -1. That is the maximum negative possible oxidation state for bromine. That is -1, and this means this is a going from +5 to -1. That is a complete oxidation change. So from the hint of the question that reaction goes to complete oxidation change, one can guess that this reaction goes from +5 to -1 oxidation state. Are you getting? We'll discuss the next problem. This was an easy problem.